Tesla has once again sparked excitement and skepticism in the tech world with its massive Gigapress machines, advanced high-pressure die-casting technology that the company has been developing since 2020. Rumors suggest these giant machines could cast an entire vehicle frame in just 30 seconds, especially as Tesla prepares for large-scale production of the Tesla Semi, expands factory operations, and hires thousands of workers. The biggest clues appeared at Gigafactory, Nevada in 2025, where enormous manufacturing equipment was delivered to the semi-production area. Industry experts believe Tesla is adapting the same Gigapress technology used in the Model Y and Cybertruck for its heavy-duty trucks. Elon Musk later confirmed that the Tesla Semi would enter volume production in 2026. Reports also suggest the upcoming Semi Gen 2 will feature Tesla's latest 4680 battery cells and a structural battery pack, reducing weight while simplifying the manufacturing process. Rather than relying on traditional assembly lines, Tesla's unboxed production method builds large vehicle sections separately and combines them later. With giant single-piece castings and structural batteries, Tesla could dramatically reduce assembly time and potentially reach its target of producing 50,000 semi-trucks annually at Gigafactory, Nevada. The final sign of Tesla's plans is its growing infrastructure network. In early 2026, the first 46 megacharger stations in the U.S. were seen nearing completion, capable of delivering up to 1.2 megawatts of charging power. Such a massive infrastructure investment strongly suggests Tesla is preparing for a rapid rollout of semi-trucks supported by breakthrough manufacturing speed. Of course, claims about a 50,000-ton Gigapress are still considered technical rumors, since the largest officially confirmed machines today operate in the 9,000 to 12,000-ton range. However, considering the massive size and structural requirements of a Class 8 truck, a significant increase in pressing force does not seem impossible. When all the available evidence is connected, the idea of a Tesla Semi Gen 2 built using revolutionary manufacturing technology no longer feels like pure speculation. Instead, it appears to be a realistic possibility supported by logical engineering and strategic developments. So what advantages would customers gain from this next-generation manufacturing process? After years of delays and promises, the Tesla Semi has finally become a real working freight truck operating on public roads. Even during a period when EV incentives in the United States are declining and electricity costs are rising, the Semi has proven it is far more than just an experimental project. Major logistics companies are now seriously testing and deploying the vehicle in commercial operations. Recent leaked images and updated reports suggest the Tesla Semi Gen 2 is rapidly moving closer to full production readiness. Activity spotted at Giga Texas indicates Tesla is not simply making small improvements, but completely rethinking the truck's design, structure, and overall functionality. One of the most noticeable changes is the exterior design. The Semi Gen 2 appears to move away from the softer look of the original 2017 prototype and adopts a much sharper, futuristic appearance inspired by Tesla's growing cyber design language. Drone footage shows a flatter and more aggressively sloped front end. This is not just for styling, it is a deliberate aerodynamic upgrade. Smoother surfaces with fewer protruding elements help airflow move more efficiently around the truck, reducing drag and improving highway efficiency. The large traditional headlights have also disappeared. In their place is a slim LED light bar stretching across the entire front, similar to the design seen on the Cybertruck and Cybercab. This gives the Semi a more unified Tesla identity while also improving aerodynamics. The main headlights are likely positioned lower and hidden beneath the light bar to maintain proper visibility without disturbing airflow. Another important detail is the windshield. While the wraparound glass design remains, The overall glass area has been slightly reduced and reshaped for better aerodynamic performance. Slimmer A-pillars also help lower drag while still providing drivers with a wide field of view. Below the front fascia, the bumper has been redesigned with active air shutters. These shutters automatically open or close depending on cooling needs. When the truck is carrying heavy loads or climbing steep roads, the shutters open to provide extra cooling for the 800-volt battery system. Under normal conditions, they remain closed to reduce aerodynamic drag and improve efficiency. This type of technology is common in premium passenger cars, but seeing it integrated into a heavy-duty Class 8 truck shows how Tesla is bringing advanced automotive engineering into the trucking industry. The mirror and camera system is also expected to receive a major upgrade. Reports suggest the Semi-Gen 2 could feature Tesla's next-generation autopilot camera system, possibly version 4.0 or even 5.0. Camera pods mounted above the front wheel arches would provide a complete 360-degree field of view with virtually no blind spots, while also preparing the truck for future full self-driving capability. Replacing large side mirrors with aerodynamic cameras would further reduce air resistance, offering both safety and efficiency benefits. While the exterior highlights Tesla's futuristic design direction, the real revolution may lie beneath the bodywork. Multiple reports indicate the Semi-Gen 2 will likely use mega casting technology through massive Gigapress machines for key structural sections of the truck. Using single-piece aluminum castings allows Tesla to eliminate hundreds of welds and separate components, dramatically reducing overall weight and simplifying production. In electric trucks, every kilogram saved can directly increase payload capacity, one of the most important factors for logistics companies. Tesla has also reportedly redesigned the side skirts, extending them closer to the rear axles to reduce turbulence underneath the vehicle. Since airflow beneath large trucks is a major source of drag, this improvement could significantly boost aerodynamic efficiency and driving range. The Tesla Semi-Gen 2 is designed to be far more efficient than traditional diesel trucks, achieving energy consumption of around 1.7 kilowatt-hours per mile thanks to its aerodynamic design and lightweight structure. One of the biggest upgrades is the new sleeper cab. Images from Giga, Texas show an extended cabin with space for a bed, extra storage, and possibly features like a mini fridge and entertainment system. This improves both driver comfort and safety during long-haul trips. Tesla has also kept its central driving position, giving drivers better visibility and a more balanced field of view. Inside, the cabin follows Tesla's minimalist style with two large touchscreens, fewer physical buttons, and more durable materials. The biggest innovation is the structural 4680 battery pack, which acts as part of the truck's frame. This improves stability, lowers weight, and increases efficiency. The Semi-Gen 2 also supports Tesla's 1.2 megawatts megachargers, allowing charging from 5% to 70% in about 30 minutes. The truck no longer feels like an experimental project. Every detail suggests Tesla is preparing for large-scale production focused on making trucking lighter, smarter, and more cost-efficient. Major companies are already showing interest. DHL tested the Tesla Semi in its U.S. fleet and reported positive results, while PepsiCo is already operating dozens of Tesla Semis in California for short and medium-distance routes. Although Tesla has not confirmed the final price, competing electric Class 8 trucks from companies like Volvo and Navistar cost around $400,000. Many believe Tesla's price will become more competitive as production scales up at Gigafactory, Nevada, where the company aims to build up to 50,000 semi-trucks per year. Tesla's planned production capacity of 50,000 semi-trucks per year is especially impressive when compared to the entire U.S. Class 8 truck market, which is expected to reach only around 245,000 units in 2026. If Tesla can fully utilize this capacity, the company could significantly lower costs and make the Semi far more competitive in price. To support these trucks, Tesla is also expanding its megacharger network across the United States. These chargers are designed to quickly recharge the Semi's massive 990 kilowatt-hour battery pack, creating a complete ecosystem focused on reliable long-distance operations for logistics companies. One of the most talked-about features is Tesla's plan to introduce supervised full self-driving technology to the Semi Gen 2, potentially as early as 2026. Drivers would still remain inside the truck, but hands-free highway driving could reduce fatigue and improve efficiency for long-haul transport. Of course, using autonomous technology in an 80,000-pound truck also raises major legal, safety, and regulatory concerns. Any accident involving self-driving technology would face intense public attention. However, Tesla's electric drive train, advanced camera systems, and central driving position may give the Semi a strong advantage over traditional diesel trucks when it comes to future autonomous operation. Overall, the Tesla Semi Gen 2 is not just designed to look better or drive more efficiently. It is built to be easier to manufacture, easier to operate, and easier to scale for mass production. For years, the Tesla Semi was considered one of Elon Musk's toughest projects. But with gigacasting technology, 4680 battery packs, improved aerodynamics, and a production system built for speed, Tesla now appears closer than ever to making it a commercial success. If Tesla's plans move forward successfully, 2026 could become the year the Tesla Semi transforms from a long-promised concept into a common sight on highways. And when that happens, it may represent more than just another electric truck. It could become a symbol of how advanced manufacturing, software, and industrial design are reshaping the future of transportation. At the same time, Tesla's push toward faster and more automated truck production also raises an important question. Is this level of innovation creating the future of transportation, or could it eventually replace thousands of traditional manufacturing and trucking jobs?